Okay, so that quiz one, that will be like 50 marks. Uh, so there will be like question pattern. So there will be five true false question will be there. Then second, four MCQ and MSQ will be there approx, and there will be nine NAT questions. So you can see that most of the question will be like numerical problem, right? So whatever the numerical in the practice exam and the grade exam, I'll suggest to you know uh, like solve 1 second without seeing the solution. That will be like very helpful in the quiz one, right? And tips is like solve all the PA and GA question without seeing the solution and watch all the lecture video. Now like we'll try to like solve some numerical question that from the practice and graded, so that we can you can get to know what type of question will be asked in the quiz one, right? Yeah, so Malex, we can start.
Yeah, sure. I hope I'm audible, right? Am I audible?
Yes, ma'am, you're audible.
Yeah, thank you. So, actually, we have questions from all the 4 weeks. I've just taken some random questions. Of course, it is from this like graded and practice assignment only. Okay, so we'll start with the first question. So the first question is a page of a web page of sizes 2 and 6 is downloaded using the WGate, and it takes 574 millisecond. So the question is, we have to calculate the throughput. So how to calculate the throughput first? Yes, how to calculate the throughput?
I will be, ma'am, the amount of data divided by the time it took.
Exactly. So what I have to do here is I have to just take oops, is my writing so visible, people?
No.
Okay, 1 minute. I'll just share my screen again. People, I have reshared my screen. Kindly acknowledge if my screen is visible. Okay.
Yeah, it's visible, ma'am.
Okay. Okay, so here what I have to do is I have to take the data usage. So what is the data used here is 216 216 kb divided by 754 milliseconds. So what I have to do here, I have to just divide it. So first they have asked only in the per second. So kb is fine. Per second they have asked, which means I have to convert the milli, which will be like 0.754 seconds and 216 kilobytes. So on dividing it, we'll get the answer of I'll just use the calendar. Calculator, yeah. So 216 divided by 0.754. So I have got the answer as 286.47. Okay. Can you able to understand this, people?
Yes.
Okay. So shall we go ahead with the next question?
Yep.
So it is mentioned that assume a host in Chennai wants to send a packet to a server in Delhi approximately 200 2000 kilometer away. If the signal travels this, so they have given the traveling like what is the traveling speed of it, and we have to find the one way propagation delay. So how to calculate the how to calculate the propagation delay? Propagation delay is equal to the
Distance by the speed.
yes, exactly, distance by the speed. So what is the distance we have here? It is 2000.
2000.
Yeah, kilometer divided by 2 into 10 to the power of 8 meter per second. So what will be the answer then? So we have to give it in. They didn't mention. Okay, they have mentioned we have to give it in the millisecond. So what I have to do, I have to take it as the meters first. Okay, so on converting to meter, what will be the value? Yes, 2
2
into
into 10 power 6.
yes, 2 into 10 to the power of 6. I think my writings are exceeding. Okay, 2 into 10 to the power of 6 meter divided by. Now how to convert this milli? So 2 into 10 to the power of 8 meter per second, right?
Divided
So
by
on calculating this, what will I get? Meter gets divided. Okay, then I have to just I'll get it in the seconds. That is 2 gets cancelled. So 1 into 10 to the power of
-2.
-2, right? -2.
-2.
So actually, I want it in a milli, which means
Multiplied by
10 to the
1000.
power of yeah. So what will we get? I'll get it as
10
10
milliseconds.
milliseconds. Is it clear? And here comes the next question. So they have asked that what this is an undirected network, which means there's no directions are given. We have to calculate the critical node. So what does mean by critical node? What is critical node?
So the node which, if gets disconnected, will divide the network into two different parts.
Yes, it gives the disconnected graph. So in this one, which point, if I remove A, will it give a disconnected graph?
No. No, it will not give.
Okay, then B.
Yeah, it will get
So yeah,
disconnected.
what will happen? It will just be like if I disconnect this one, I'll just get it as D and E different and E separately, something like this, right?
Correct.
Yeah, so we won't get the proper one. We'll get the disconnected one. So that's why
No,
I
so
will say this
D
as
D is also critical node, right?
mm. See,
Is that
actually
correct?
no. The thing is, A is connected with like the whole graph forms in such a way that B is connected with C. So if I remove that, what will become? C becomes a different graph and DE becomes a different graph, right? And A becomes a different graph because
Yeah.
A, C, D were connected only through the B.
Yeah, but what I'm saying is that B is correct. B is critical node, but D is also critical node, right?
Huh?
Yeah.
Because that also disconnects into the different things.
Yeah.
Okay. If I take A, it is not a critical. C and E are also not the critical one.
Correct.
Okay. Fine. So now moving to the next question. So a
One
fiber
question.
optic.
Could we go back to like the previous question? Just like one
Yes.
question before this.
Okay.
Yeah, I actually, I mean, I couldn't follow this computation. If you don't mind, could you just like derive the computation here? How did we convert from 1 into 10 raised to power minus 2 seconds into milliseconds?
See, if I have to convert into what into the like 1 into 10 to the power of minus 2, I have to convert it to a millisecond. So I am multiplying it by 1000. That's it.
Okay.
Which means like 10 to the power of 3, right?
Understood.
So what will be the value I'll get? Minus 2 plus 3, I'll get it as power 1. So 1 into 10 is like 10.
Okay,
The
understood.
same way, I'm just multiplying by 10 power 3. That's it. Because it is in, we need it in millisecond. That's why. Okay. All right. Here comes the next question, people. A fiber optic link is 45 kilometer long, and if the signal propagation speed is in the fiber is 2 into 10 to the power of 8. So what is the propagation delay? Yes. So previously we have discussed what is propagation delay. What is propagation delay, people? We have to take it as
The distance
Speed
by
by time.
yes, exactly. I have to take it as distance by speed. Okay. So what I have to do? That is what is the distance here? 45 into 10 to the power of 3 meter, right? Divided by, here I have got 2 into 10 to the power of 3 meter per second. And they said we wanted in the micro. Okay, so on calculating this, what will we get, people? What is 45,000 divided by 2 into 10 to the power of 8? Let me use the calculator. We'll get 2.25 is the value we are getting it, right? 2.25 into 10 to the power of minus 4. But what we need, we wanted it in the micro. So I have to just multiply it by 100. So what will be the value then? 225 microsecond. Okay. Is it clear?
Yes.
yes.
Okay, shall we go ahead with the next question then? Okay, a router needs to transmit a packet of size 1000 bits over a link with the transmission rate of 50 Mbps. And what is the transmission delay? So how to calculate the transmission delay? size of the packet divided by transmission. Yes, transmission rate. So what is the point here? Like 2000 bits, and here we are getting 50 megabytes per second. Okay, so here what will be the balance answer then? 2000 divided by 5 will get it as 4, right? In short form, you can write it as 2 into 10 to the power of 3, right? And divided by 5 into 10 to the power of 7. So what will be the answer? We'll get 4 into 10 to the power of minus 5. Is that clear? You're not able to understand this, ma?
Yes.
So for transmission delay, we are taking size of the packet divided by the transmission rate. So packet size is 2000 bits, and this is of 50 Mbps, like transmission rate. So we are dividing it. We are getting as 4 into 10 to the power of minus 5. That's it. And here is the next question. Network link has a bandwidth of 2 Gbps and a propagation delay is given. We have to find the bandwidth delay product. How to find the bandwidth delay product? Yes. We have to multiply, right? Whatever the bandwidth we have, which has to be multiplied with the delay. Which means 2 Gbps has to be multiplied with meter per second. So what will be the answer? Which is 2 into 10 to the power of 9, right? And then 20 into 10 to the power of minus 3. So what will we get?
40 into 10 to power 6.
Yes, 40 into 10 to the power of 6. So 10 to the power of 6 means it's megabytes.
Yeah.
Is it clear? Okay, so now here comes the next question. So consider the 16-bit words that are used in the checksum calculation. Okay, so here first we have to sum all the words. So you all know, right, how to take the 16-bit values. So
Yeah.
0 to 9 will be same. For 10 we have to take it as A. For 11 it's B, and 12 C, 13 D, 14 E, and 15 is F. Now they are adding A's. So what is 0x? All the A's are taken and added with 1. So what will be the value then? Added up value? B's. Right?
Yeah.
Okay. Now this has to be added with 0x 2222. Then
D.
yes, we'll get all D's. Now this has to be added with the F values. What is the value of F?
15.
13. So we'll get it as 28. Which means we can say 16 plus 12, right?
C.
Yeah. So we'll get it as C, C, C,
And
C.
C.
And we have one carry, right?
Yeah.
Actually, here we'll get C and we'll get 1 as the carry.
Yeah, correct.
So here it becomes as D then, right?
Right.
So what happens?
Again, it one
What-
carry and then D.
Yeah.
One carry and D. Yes.
So it will become as D, again 1 carry, D,
Then
and
1.
again, yeah, 1. So we have this is the value. So now I have to add 1 to all. So what will happen?
D 1.
Yes, now I'll get all the values is these. And in the starting we have the 1.
1. Yeah.
Sorry, we all same only, right? Yeah, we have to add 1, so we are getting all these. So this is the added up value. So now what they are asking, we have to take the overflow adding count. So if I take this overflow and if I add here, what happens?
F,
Zero.
F, F, F. Yeah.
Array, D plus 1, right, which becomes an E. See,
Ah, correct. Yeah.
so it becomes the hexadecimal of 0x, 0x, DDD. Only this is added with 1, so that becomes an E. That's it. Now we
Yeah.
have to take the 1's complement. So what will be the value? How to get 15? E plus what I add if I get 15?
How
1,
much
right?
to add? Yeah.
I wanted to get all F's. So what do I have to do?
So
You can
we
just write
will
it like this.
subtract
0
from
is,
F, then we'll get the value.
yeah, exactly. Because it's a 16th value, like 16 complement, no? So you can just take like this. So what I'll get? I'll get here is 1.
1,
All the
2,
remaining
2,
values are
2.
2.
Yeah.
So here they have asked what is the value of it, right? So the answer has to be 0 to x triple to 1, but it is not present here, right?
Right. None of the.
None of the above will be the answer. And here is the next question. So they
In
have
the previous question, if this question comes as a NAT, should we include 0x in the answer, or can we ignore it?
We'll consider all the answer. Like if you are written 0x also, and if you are not written 0x also, we'll take all the answers. So don't worry.
Okay.
all right. So proceeding with the next question, people. So we have the bandwidth delay of 800 kbps. I mean 800 kb, and they have said that the required window size to fully utilize the link is 400 packets. So now they're asking what is the packet size. How to calculate this? What so BDP
First,
can be like
BDP is bandwidth into propagation delay, I believe.
and the other
And
ways
then,
are window size into
sorry?
the other ways are BDP is equal to window size divided in window size into packet size.
Packet size, yeah.
So on considering this, I want the packet size. I have this as 800 KB and I have this as 400 packets. Now I need to calculate this packet size. So as usual, like normal division way, packet size is equal to 800 KB divided by 400 packets. So what will be the answer here?
2.
Yes, 2.
So 2 KB.
Yeah, that's it. Okay, is that clear?
Yeah.
Okay, so now proceeding with the next question. Okay, they have mentioned us in a go back in protocol with the window size of 4, the sender transmits the packets 1, 2, 3, 4. Suppose the packet 2 is lost, but the packet 3 and 4 are received correctly at the receiver. So what is that? When the timeout for the packet 2 occurs? And how many packets will the sender retransmit? So the
2 onwards, everything, I believe. 2 and
yes, exactly.
everything.
Because only the 2 started getting an error, right? So what it will do, it will start from 2. So 2, 3, 4 will be delivered. Okay. Because the acknowledgement for that 2 is missing, so they'll just start to from the 2. Is it clear?
Yeah.
Okay, so the next question is, in the selective repeat ARQ, if the receiver window size is 5, then the minimum sequence number space might be at least. So generally, what is the sequence number space? Which has to be
2 times the window size.
yes, should be greater than the 2 times the window size. Because I'm saying greater than or equal to, which means be at least. So what will be the value? Then 10, right? So here we'll get
How,
the same.
how did 2 times come? Factor 2?
And that is the way, no? Like if I have to find the sequence number space. So let's say the like in selected repeat ARQ, the thing is let's say the ambiguity between the new and old packet. So that's why they'll just have this sequence number space has to be greater than or equal to 2 into the window size.
Okay.
Because the thing is, let's say there is a issue. So what will happen? It will start from the like it will start transmitting the new ones, right? Is that clear?
Let's say there is an issue in the third packet, and so since it is selective, and it's initially send the first 5 packets, and third packet is as an issue, and so why it can't again send packet number 1? Means why you should start with 6 sequence
I didn't
number.
understand your question.
My question is regarding the size of the sequence. Now, in this case, if there is an issue with the third packet, and all the remaining 4 packets are in buffer, so it will resend the third packet. Since it is selective repeat ARs.
Okay.
Yeah, then what is the necessity of having double of it? You are happy with it is resending the third packet, right? So why should you have 6th packet, 7th packet, and sequence like this?
Actually, it will just use that same sequence number will be reused, right? Is that your
Yeah.
question?
Yeah, why can't we use the same sequence number? Why should it to start with 6 sequence number 6, 7, 8, 9, 10? What is the necessity of it?
Let's say it is just okay, it is just taking the old retransmitted frame for a new one. So let's say if it is taking the old transmitted frame for a new one, there will be a confusion, right? So that's why the sequence number is repeating again.
Okay, but it is selective, right? So it can just send sequence number 3. Again, since we found out the error is in the third packet, so it can just send sequence number 3.
Yeah, I
So,
understand. See, if n is 2 is small, right? So then old frame, whatever the previous cycle, so may reach the same sequence number as the new frame, right? What you like send. But the problem is it will confuse the receiver from the receiver side. So because it might mistake and like old transmitted frame for the new one. So it will be like confusion for the receiver side. That's why you are taking the greater than 2. That explanation is given in the lectures, so you can watch in the lectures. That will also it will be helpful.
okay, thank you.
I hope that is clarified, right? Okay. So here we have a sliding window protocol. Like they said that we have a 1 Mbps which has a one-way delay of 1.25 seconds, and they mentioned that each frame carries the 1 kilobyte of a data. So what is the minimum number of bits you need for a sequence number? So here the link bandwidth is given, one-way delay is given, frame size is given. So how to calculate that?
We might need to compute the bandwidth delay product and then
Yes.
get
What
the
is BDP? So for BDP, we have to take the bandwidth.
Bandwidth into propagation delay.
So what will be the value here? We have to take as bandwidth is 2.
2 into 10 to power 6
Hmm.
into
And then
1.25.
it should be 1 into 10 raised
first
to
I have to no. I'm just calculating the RTT here. That is round trip.
Okay.
That is what I'm calculating at first. So in the round trip, what I have to do? 2 into 1.25, right? One-way delay I'm taking, and I'm taking it for the round trip.
Mhm.
Okay, so what will be the value I'll get? I'll get it as
2.5.
2 seconds. This is my RTT. So here I have to multiply it with the RTT only. So bandwidth is 1 into 10 to the power of 6 into this 2.5 has to be multiplied. So what will be the value we get? 2.5
2.5
10 to the power of 6 bits. Okay, so what I have to do then? Next, I have to calculate the window
kilobytes.
size, right? No, we have to find the window size, no?
That's how in this case.
So how to calculate the window size?
So we can use the sequence number formula.
No, we have the BDP, right? And we have the frame size. So what we can do, BDP equal to frame size into window size. We can use that one, right?
I forgot the formula, but okay.
Previous
Yeah,
also
so window.
for BDP. Okay, so like window size into packet size or that frame size. Okay, so we are using the same thing here, and we have to but here we have the BDP and the frame size, so that has to be divided. So what is the BDP, which is 2.5 into 10 to the power of 6, and what is the frame size, people?
1 kilobyte.
8 into 10
Yes, 1 kilobyte is how can we represent it? Like, okay, let me just give it as 1 into 10 to the power of 3, right?
Into 8.
Because one, okay, so I have to just 1024 them, right? 1 kilobyte is, so I have to give it as 1024 into 8, isn't it? Which is 8192. So 2.5 into 10 to the power of 6 divided by 8192. So what will be the value we'll get? I'm just using the calculator for this. 2.5 divided by 8192. Okay, so we are getting us 0.0003. Okay, we can just write it as approximately 305.8. Sorry, 18. Is it clear?
Yes.
Can you able to understand till the step, people?
Just one question. When we are computing the bandwidth delay product, we have to take RTT, the one-way delay product.
Yeah, because it's a one-way delay, no? So I'm taking as a round trip.
So when we are computing, we have to take RTT, is it?
Yes.
Okay.
And then now we have to find the minimum sequence number. So generally, what will be the sequence space number? We have said that it has to be 2 into the, I mean, like window size has to be 2 into n, right?
Yes.
Just now we have discussed, no?
Yes.
Sequence space number has to be greater than or equal to 2 into the window size. So here we have the value as 305.18 into 2. So what will we get, people? Or let's say we can approximate this to 306. So we'll get 712, right? That will be the minimum number of bits required for the separation.
612.
612.
612. Oh, sorry. 612. Is that clear? So far we have calculated the sequence numbers. Now what we have to do? We have to calculate the number of bits needed for this. So you know that, right? 2 to the power of b has to be the number of bits we'll just take, isn't it? So this has to be greater than or equal to that 612. See, generally it has to be the 2 to the power values. So you know, right, what is the 2 to the power of 1 value is 2 and 2 to the power of 2 is 4. You all know that, right? And 3 will be of 8 and it will be of 16, 4 and 15, 5 is of 32 and then 64 and then 128 and then 256, then
512.
yes, then what is the next value? 1024. So it has to be greater than 612, which means it has to be greater than this value. So this is of 5, this is of 5, so it has to be 10. So b value has to be 10. Is it clear, people?
Yes.
Because it has to be greater than 612, so I'm just taking more than 512 is 1024. And here's the last question. In the stop and wait ARQ system, the link utilization is measured to be 5% if the round trip time, that is RTT, is 95 meter per second. So what is the transmission time? Yes, what is the transmission time, people? So for the link utilization, we'll take it as, what are the things we have to take?
Transmission by
Packet transmission time, yes, divided by,
transmission plus RTD.
perfect. So the same packet transmission plus RTT. So here we have to find this packet transmission, right? So what I have to do, I have to ulta it, right? That is, here the utilization is of 5%, which means 0.05 is equal to PTT divided by PTT plus, what is the RTT? 95 milliseconds.
Round trip time.
So
Yeah.
how? So if I write it in the seconds, how can I write it? 0.095 seconds, right? So now I have to take all these things to side. That is 0.05 PTT plus 0.095 equal to PTT. So now taking PTT all on one side, so I'll get 0.095 is equal to This is of 1, right? And this is of 0.05. So I'll get it as, no, actually this also need to be multiplied by 5, right? I'm missing that step. So 0.05 5 into 0.095. So I'm getting the value as 0.00475. So now keeping this on the one side, that is 0.00475 on one side, taking this to the other side. So I'll get it as 1 minus means 0.95, right? So 0.95 PTT. So keeping PTT on the one side, I'm just giving us 0.00, or else we can keep it like this itself. Instead of multiplying, I can keep it as 0.05 into 0.095. Okay, so now I can give it like PTT equal to 0.95 divided by this one, 0.095 into 0.05. So here we are getting the answer as 5, right? Yeah, 5. That is 0.005 will get. We can just take it as 5 millisecond. Is it clear?
I think the last step is inverse. The numerator and denominator got changed.
Mm-hmm. Okay, I have written it. 0.05 into 0.095 divided by 0.95. Yeah. Yeah, okay. Any other doubt, people, in this?
So I have some,
Graded assignment.
I have some few questions. I like the content about like computer network. Like you now week 6 is going on. Like week 6 will be content will be rigid in this Friday. So did you like up to week 5? Anything missing is there or?
No, the content is fantastic. So far I have liked it.
Oh, okay. And assignments are like you are liking it, right? Like practice assignment and graded assignment.
Yeah, assignments are also like pretty straightforward. So
Oh, okay. Yeah, and for the quizzes, like if you want to good score, then it is like simple. Like just have to watch the lecture video and solve all the questions, practice assignment, graded assignment, whatever the assignment you have given, without seeing the solution. If you stuck, then just message in the group or message me like personally also. We'll get the answer, right?
okay.
Yeah. And Gautam, what is your doubt?
Yeah, there's a doubt on week 3 graded assignment, 8th question.
Okay, question. Yeah, I think this we have discussed in the group itself, right? We have
So,
in the
okay.
in the
Discourse
group also.
or
No, in
I
the
mean,
normal group we have discussed.
oh, GSpace, okay.
Uh-huh.
So we've all kind of found this question a little bit confusing as to what exactly was expected.
Oh, okay. So yeah, this type of question like we won't be there in the quizzes. Don't worry.
Okay.
Yeah. Okay. Any other questions? Okay, then all the best for the quizzes. Do well in the quizzes. Thank you, everyone. Thanks for joining.
Yeah, thank you.
Thank you so much.